Hello, y'all. Welcome to lesson 57 of my DP chemistry curriculum. This is an HL lesson. We're going over structure 2.2.3, transition elements with their delocalized d electrons. So we're going to explain the high melting point and electrical conductivity of these elements. Many of these are going to be further covered in 3.4. However, let's just go with melting point and electrical conductivity. So transition metals, or more often referred to as transition elements, these also form ions with different charges. So this is the biggest difference between them and regular metals. So regular metals, specifically like our S and P block metals, these usually have one charge. So like group 1 is +1, group 2 is group 2. However, D block metals, D metals, or you know what, D block metals is how we call them, or our transition metals, usually have 2 to 3 to sometimes 4, 5, and 6 charges. So we'll just say many charges. Now there is an exception which we learned about when we talked about transition elements first, which was zinc. So we're not going to be talking about zinc throughout this because it only has the one charge of 2 plus. However, uh, we will refer to most of these as our D block metals, and we have to know that they have these different charged cations. Furthermore, they have many valence electrons because we also include these d orbitals. And due to those many valence electrons, this is all across the s and d orbitals, we can have a greater electron density in the lattice. So if we have that greater electron density in the lattice, therefore, we're going to have a stronger metallic bond. So basically, the big thing here is they have a lot of valence electrons across their orbitals, therefore greater electron density, and therefore a stronger metallic bond. And then this follows the same trends that we talked about before with our S and P block metals. So starting with melting point, whoops, starting with melting point, we're going to expect a very high melting point, and that's due to many delocalized electrons creating a strong bond. So we're going to have that very, very, very high melting point, which again will not include zinc because it only has a 2. So this is our general trend for our D block or transition elements or transition metals. They're going to have a high melting point. So we have another one. We could talk about hardness. And with hardness, very much the same. We have a strong bond and therefore high hardness. You can think about this with like sodium or potassium. You can cut those with a knife, but now imagine trying to cut a piece of iron or trying to cut a piece of tungsten even. It's not going to happen the same way. It's going to be much, much more difficult. The biggest one of our concern here is actually electrical conductivity. And so this is a big one because this property is used a lot in industry to T. So the one thing we know when you think about D block metals like copper or gold or silver is these are very conductive. So D block metals are known to be incredibly conductive, and that's once again because of all those electrons. So as our attraction between or within metallic bonds, traction in metallic bonds increases with more d block electrons, more d orbital electrons, so does the conductivity. We have more freedom of movement with those electrons. With those electrons. So these d orbital electrons, they actually can move a lot more than s orbital electrons. And these are also going to contribute to that conductivity because once again, electrical conductivity is just the movement of charged particles. And these transition metals have some of the most free moving electrons as to anything else. Our biggest example is going to be, of course, copper, because we use it in wiring mostly, and it's just an incredibly conductive element that we can use in everything. You literally can open up any electronic and you're going to have copper through the wiring. So this is the main property. These are the main properties we're talking about with transition metals that you need to know in HL. You need to know that they're going to increase in these properties because they have more delocalized electrons. They have multiple charges, so this can be varied. And finally, they have that high electron density in their d orbitals, so they're going to have a very high electrical conductivity, hardness, and melting point. So I hope this helps and have a great day.